Hello friends, this is Jim with Science Talk. I have a story here dealing with Antarctica and refers to the buffer that is provided by the sea ice that forms around the continent. So, what do we have going on here? We have this very large ice sheet on the continent. And in a new study written by U.S. scientists published in the journal Nature, indicates that the southern ice sheet that has been had this protective buffering, if you will, of sea ice around it, is now being threatened. We're now seeing that swells from the north are basically flexing the sea ice, because don't forget, the sea ice is frozen, it's sitting on the water, so there's swells here, so there's starting to be some flexing of that ice, which is causing the ice to weaken, and so doing can destabilize what's called the seaward edge. There's the edge facing the sea, basically the edge of the ice. Couple that with regular infiltration, inundation by summer meltwater as the edge breaks away, can also add to this rapid ice shelf disintegration. So what's going on here is the sea ice is a protection. Well, if you lose the sea ice, now the land ice itself, don't forget, is a part of it that protrudes out past the coastline, if you will, protrudes out into the ocean where it's met up by the sea ice. You lose that sea ice protection, now the land ice is now subject to wave action and so forth. That can start breaking it down. And then add meltwater to that, and you have a further degradation. So when we have ice shelves, and we have, with their ring of sea ice around it, there are thick plates of ice fed by what's called tributary glaciers. And these are basically the floating seaward extensions of the grounded inland ice sheets, these huge, massive inland ice sheets. They tend to slow the flow of ice from the sheet, so any rapidly disintegrating shelves can lead to further ice migration out to the sea, and in which case they are then lost, melted, in other words, and the result is you have a contribution to increasing sea level. So, Ted Scambos, who is a co-author of this study, he's a senior research scientist at the NSIDC, the University of Colorado Boulder. NSIDC is the National Snow and Ice Data Center. And he says that sea ice, basically, he makes the analogy that they act like bumpers on a car. With the bumpers in place, the car can take a shock and not be damaged. Take them off, and well, next thing you know, your radiator is leaking antifreeze, right? And basically, he's equating the sea ice to this bumper system in the vehicle. You lose the sea ice, and now the land ice is more vulnerable. That's the essence of it. Since 1995, 3 large ice shelves on the Antarctic Peninsula, Larsen A, Larsen B, and Wilkins, have suddenly and dramatically disintegrated, occurring over a few weeks or sometimes even only a few days. These breakups indicate an unprecedented departure from the more typical and natural recurring calving of larger icebergs every decade or so. And we've probably seen some of the dramatic satellite images of massive bits of ice sheets just suddenly breaking off, and there they are in the ocean. So, an example of science continuing to always look for mechanisms and answers to questions. Until recently, researchers had thought that intense surface melting caused by warming the atmosphere and so on were the culprits, the reason why ice sheets were breaking. But the new findings suggest that loss of sea ice and the calving of the seaward edge into narrow sliver-like icebergs are the trigger that sets off a rapid ice shelf disintegration. There are several factors at work here. Our study breaks new ground in how it implicates sea ice change in sea level rise, said Rob Masson, who is the study's lead author. He's also a senior research scientist at the Australian Antarctic Division, as well as the Antarctic Climate and Ecosystems Cooperative Research Center. That's a mouthful. It introduces ocean wave-induced breakage of the outer margins of ice shelves following loss of a protective sea ice buffer, basically as the straw that breaks the camel's back. He and his colleagues analyzed disintegrations on 3 ice shelves that have been stable for centuries, perhaps even millennia. Larsen A in 1995, Larsen B in 2002, Wilkins in 2008 and 2009. They confirmed that atmospheric warming led to increased meltwater on the surface of the shelves. Pooled meltwater will then percolate downward through crevasses, setting off a hydrofracturing process that weakened the ice. And we're seeing a similar mechanism at work on the Greenland sheets. Earlier studies have identified the central role that ice shelves play in making sea level rise more likely and the accelerating pace of Antarctic melting. So in essence, now sea ice itself, when it melts, does not contribute to sea level rise because sea ice is formed from freezing the seawater. Right? We have brine rejection and so forth. But the point here is, if you lose the sea ice itself, then there's nothing protecting the land ice. And now the land ice is more vulnerable to breaking up. And when that breaks up and splits off from wherever, Greenland, Antarctica, and so forth, and currents carry it to warmer waters where it will melt, that will contribute to the increase in sea level rise. That's basically the mechanism, the scenario that's going on here. But here's the crucial point. What the NSIDC analysis reveals is a previously little recognized link to sea ice. All 3 disintegrations happened when there was little or no sea ice cover along the shelf edge. Without that protective buffer, shelves became exposed to waves which flexed the already fractured ice and thereby hastening its splitting and disintegration. So Scambus continues, what we found is that increased flexing of the outer parts of ice shelves by waves sets the ice up for destruction. Even though the movement is tiny, over time the shelf is weakened. In each case, ocean swells began affecting the ice shelf edge. As the shelves flexed, existing fractures along the seaward edge chipped off as long, thin, sliver-shaped icebergs, not the larger tabular icebergs more typical of Antarctic ice shelf calvings. The remaining ice shelf was then ripe for runaway collapse, basically setting up an accelerating situation. Other ice shelves can survive for centuries if they don't have surface meltwater or if the water can run off easily. But if the meltwater is pooling, ponding, starts spiraling inward, like drilling a hole through the ice, then that's a different situation, then you're weakening the ice. Because ice shelves are already floating in the ocean and displacing their volume, think of ice cubes in a glass of water. Now, I've done previous videos discussing, ice shelves that are grounded versus ice shelves that are not grounded. And if it's not grounded, you could have warm water underneath melting the ice from underneath, thereby also weakening it. Now, the ice shelves, as long as they stay in place, can provide sort of like a back pressure, sort of like a stopper that will help moderate how fast the glacier will move. If they're in place, the glaciers may move slowly. You lose that, then there's nothing holding back those glaciers, and they can go galloping off to the sea. So Dr. Massa basically says this represents an important pathway towards reducing current large uncertainty in predictions of the response of the Antarctic cryosphere to climate change and its contributions to sea level rise. Translation: we now have another piece of the puzzle, another piece of the mechanism that will help scientists predict the rate of loss of the ice, and therefore, if you know that rate of loss, you can make more accurate predictions on what's going to happen with the increase in sea level. The Antarctic ice sheet contains enough ice to raise sea level by approximately 57 meters. That's about 187 feet. Okay. Worldwide, more than 100 million people currently live within 1 meter of mean sea level. That's 100 million people living within 1 meter of mean sea level. How many people worldwide live within, say, 100, let's say 50 meters of mean sea level? There's a potential for a lot of people to be displaced. We're going to have people displaced not only from rising sea level, but also as certain regions of the earth, land areas, become too hot to live. Areas like in the Middle East. Predictions are that soon they'll be so hot, temperatures in the 140s, 150s, good grief, that it just becomes uninhabitable. But also, when that becomes uninhabitable, we can't grow crops. So we're going to lose land for people to live in, but also land to grow food. I'm sure you've heard about the recent IPCC report. IPCC tends to really underestimate how bad things are. And for them to basically saying, okay, we have to have zero emissions by 2050, but they then turned around and said, we need to do something drastic right now, or by 2030 it's game over, was too late. Coming from the IPCC, that's about as, like a 10-alarm blaze going off. So, and now with everything else, we've got these positive feedback loops that are being set up there that are going to help accelerate and make things worse, at least for humans. So it's getting dicey out there. Anyway, I want to bring you a report that basically you lose the sea ice, you lose the buffering, and you help accelerate the loss of land ice into the ocean. Where it gets warmed up, it melts, sea levels rise. That's basically the summation of this report. Thank you for your time. Hey folks, just a reminder to please subscribe and click the bell so you know when I drop a video. Please share my videos. Please tell others of my channel and of the work that I do. I also hope that you will consider becoming a patron at patreon.com/Science Talk with Jim Massa, where from time to time I upload videos there exclusively for my patron subscribers. Details in the description box below. Thanks.